मित्रांनो, आपण मागच्या काही क्लासेसमध्ये लाईटशी संबंधित अनेक फिनॉमिनाचा अभ्यास केला. ज्यापैकी बहुतेक फिनॉमिनन आपण बघितलं की आपल्याला रे ऑप्टिक्सने एक्सप्लेन करता येतात. त्यांना आपण बेसिक फिनॉमिना म्हणतो. आज आपण जो फिनॉमिनन शिकणार आहोत त्याचं नाव आहे इंटरफेरन्स ऑफ लाईट. दिस फिनॉमिनन वॉज डिस्कवर्ड इन 1800 बाय थॉमस यंग. This is a characteristic phenomenon associated with light which couldn't be explained on the basis of ray optics, because this phenomenon is based on the fact that light is propagated in the form of waves, that is wave optics. This phenomenon was difficult, or rather is difficult, to observe in day-to-day life because it needs some specific experimentation. It's very simple observation that in certain room, if you lit one bulb, whatever light you get of particular intensity, if you lit another bulb of the same type, you will get intensity almost double at every point in the room, in every region of the room. But if the same experiment with the help of two sources which are characteristically designed is performed in laboratory, it can be seen that in some of the region you will notice, or you will get unexpected darkness or unexpected reduction or enhancement in the intensity of light, which couldn't be explained on the basis of ray optics. This type of experiment was first performed by Thomas Young in 1800, and he found that at certain point where the light is reaching from two different sources simultaneously, there is a redistribution of intensity of light. He couldn't explain this redistribution on the basis of ray optics, and he called this phenomenon as interference of light. Similar phenomenon is very easily observable in some other forms of waves, that is sound waves, electromagnetic waves, etc. And on the basis of this experiment, he came to conclusion that the light must be propagated in the form of waves and not at all in the form of particles. And that is the reason this phenomenon is called as characteristic phenomenon, which confirms wave nature of light. Isn't it? The reason is very straightforward. This phenomenon could not be explained on the basis of ray optics, but same phenomenon could be well explained on the basis of wave optics, in which basic principle or basic assumption is that light is propagated in the form of waves. If we assume that light is propagated in the form of waves, it is quite obvious that the light has to obey all those principles and laws which are there or stated for any wave motion. One of such principle is called as principle of superposition of waves, which is very common for all kind of wave motions, including electromagnetic waves. This phenomenon could be well explained on the basis of principle of superposition of waves, and that is the reason why Thomas Young said or suggested that this confirms wave nature of light. Now, in very simple one language, let us see the definition of this phenomenon first. The redistribution of intensity of light at a point where the waves are reaching, light wave of course, they are reaching simultaneously from two different sources. This redistribution of light energy at that point is called as interference of light. The redistribution of intensity of light at a point where light is reaching simultaneously from two, of course, or more different sources, satisfying of course certain condition, is called as interference of light. If we want to understand the interference, first of all we have to understand the principle of superposition of waves, because on the basis of this principle only we can explain this phenomenon. So first of all, let us study the principle of superposition of wave. Now the word superposition itself gives you some idea about this principle. Now what is a wave or wave motion? You have clear-cut idea about wave motion, that when any wave arrives at any point at any instant of time, it produces displacement of that point. Now this displacement which is produced by that wave, it is momentary displacement. The maximum displacement is called as amplitude, and square of amplitude decides the intensity of light at that point. That also you know. Now this principle tells you that if the two waves are reaching simultaneously at any point, then the resultant displacement of that point, if x is displacement, the resultant displacement of that point is given by vector sum of the two displacements or displacements due to two waves. when the two waves are arriving at that point simultaneously. If x is the resultant displacement and x1 is the displacement at a certain point due to first wave and x2 is the displacement due to second wave coming simultaneously at that point, then the resultant displacement is given by x1 plus x2. Of course, note carefully that it is a vector sum. You know the rules of vector sum. In vector sum, 5 plus 3 not always become 8. It can be anything between 2 and 8 magnitude we are taking. Now, if this principle is applicable for displacement, this should be applicable for maximum displacement. And the maximum displacement is called as, of course, amplitude. And therefore, the amplitudes of the two different waves which are interfering, that also obeys this principle. And as the amplitude obeys that principle, the resultant amplitude which decides the resultant intensity at that point, that will also obey this principle. And you notice that if I say that y1 is displacement due to first wave and y2 is displacement due to second wave, maximum displacement, that is amplitude, then I can consider it as a scalar, and then I will say the resultant amplitude at that point due to superposition of these two waves having amplitude say y1 and y2, that resultant amplitude will be y1 plus y2. y1 हा पहिल्या वेव्हचा हा दुसऱ्या वेव्हचा. So that is the resultant. Now you know this sum, although I have not put here vector, don't forget that it is algebraic sum. Here you have to take algebraic sum. I hope all of you know the difference between algebraic sum, ordinary sum and vector sum. Of course, this is algebraic sum is a special case of vector sum. Here I have assumed that the displacements are collinear. And therefore, y1 plus y2 will give you some value between y1 plus y2 and y1 minus y2. In other words, the maximum displacement will be y1 plus y2 and minimum displacement will be y1 minus y2, and the resultant displacement at that point will be in between these two. Now the interesting thing is that this principle or this equation will help us to find the resultant amplitude, and the square of resultant amplitude gives you intensity of light at that point. And as it is an algebraic sum, mind well carefully, as it is not ordinary sum, as it is algebraic sum, it can have variation. Sometimes this algebraic sum will go beyond certain expectation and sometimes it goes below expectation also. I will give simple example. Suppose I have one source of intensity say 25 units and the other source of intensity say 16 units. Then when two waves come simultaneously at certain point, we expect that the resultant intensity must be 25 plus 16. But you notice, we will show mathematically later on, that the resultant intensity may go sometime beyond your expectation, or sometime at some point it may go below your expectation also, because this is an algebraic sum. And that is the reason why resultant intensity at certain point, as I mentioned in this experiment also, somewhere you get where the interference is occurring between two light waves, separate light waves coming simultaneously, the resultant intensity may be less than your expectation or may be greater than your expectation, and that is the phenomenon of interference. When the experiments were carried by Thomas Young and then the results were applied with this principle of superposition, he came in exact agreement. These two things came in exact agreement, indicating that or confirming the fact that light must be obeying the principle of superposition of wave. In other words, it is nothing but in the form of waves. Of course, at that time it was supposed that it is in the form of mechanical waves. Later on it is confirmed that it is in the form of electromagnetic waves. Don't forget that this principle is applicable equally for mechanical waves as well as electromagnetic waves also. What the point? Now let us see a little mathematics behind this phenomenon of interference of light and try to understand different conditions, that is what we say, different possibilities in interference about the intensities. For that purpose, let us consider two different sources. You know, general expression for any wave is given by, if x is amplitude of any wave or the result displacement of any wave, you know, general expression for any wave motion is x is equal to y sine omega t plus some phi, plus or minus phi. Here you must be knowing that it is equation of sinusoidal wave, very general equation. This is the instantaneous displacement of the particle of the wave. This is maximum displacement, that is amplitude, because maximum value of sine of any angle is 1. So maximum amplitude, maximum displacement is amplitude. This is called as phase angle. This is called as phase angle. This is phase of the wave. I hope all of you know these things. Now let us consider two different waves which are having the equations. One wave is having displacement x1, amplitude y1. Angular velocities will be same for them. Displacements may be angular displacements will be different. Means phase difference will be phase angle will be different. Here it is say phi1. There is second wave, suppose, of which the equation is x2 is equal to y2 into sine of omega t. Omega is same, angular displacement is same. त्यांची velocity, angular velocity म्हणजेच wavelength is same, period is same for those two waves. This is basic condition. Even if this condition is not obeyed, interference will occur, no doubt. But systematic study, for systematicness, we have taken these two equal. Now let us suppose that at certain point P, the two waves arise simultaneously, these two waves. And suppose that the resultant intensity at that point is x. Now according to principle of superposition of waves, this displacement, resultant displacement will be given by x1 plus x2. Of course, this is according to principle vector sum. Now I want to talk only about maximum displacement which gives you amplitude. So I will say if resultant amplitude is yr here, then the resultant amplitude will be y1 plus y2. But do not forget, although I have used sign plus here, it is a algebraic sum. Here we may mention also that this is algebraic sum. I hope all of you know how to find algebraic sum. For a moment, you can consider, for better understanding, you can consider it as a vector sum also. And I hope you understand that if you take it vector sum, then magnitude of yr will be given by, I hope you know, y1 square plus y2 square according to your law of parallelogram of two vectors, plus 2 into y1 into y2 into cosine of phi1 minus or phi1 difference phi2. I hope you have to take square root of all this. This gives you yr. That is resultant amplitude at that point will be given by this. You know, resultant amplitude is this one, and square of amplitude gives you intensity, and therefore resultant intensity at that point is given by the equation. Is if you take square of this, square root sign will go. So here you will get y1 square plus y2 square plus 2 into y1 into y2 into cosine of phi1 difference phi2. For convenience, you can take phi1 minus phi2 also. I will take phi1 difference phi2. I hope you know meaning of this sign. Now you know y1 square is I1. It is the intensity of light at that point due to first wave. y2 square is similarly I2. So this is I1 plus I2. This is 2. This is root I1 root I2. I will write collectively as root I1 I2 and into cosine of phi1 difference phi2. Okay, now note very carefully, this gives you resultant intensity. So actually speaking, this is the final equation of resultant intensity at that point. And now you notice carefully, as we have taken the first example, the expected intensity at that point in ordinary case we expect is just I1 plus I2, that is the addition of two intensities. But the resultant intensity at that point is not only addition of these two, it is something else. This is additional factor, and notice it involves cos here. So you know this factor may be positive or negative. That tells you that sometimes the resultant intensity at that point may be greater than expectation or expected value. Sometime it may be less than expected value. Of course, sometime it may be equal also. That all depends upon, note carefully, values of phi1 and phi2. That is the phase difference between the two interfering waves will decide how much is resultant intensity at that point. And I think it is now not difficult to understand that you know that maximum value of cos of any angle is +1 and minimum value is -1. So the resultant intensity from this equation, I say the maximum possible intensity will be available, and that will be equal to the expected intensity I1 plus I2, and in addition to that you will get intensity additional factor is 2 root I1 I2 which is getting added. So this will be the possible maximum intensity at a point of interference. Consequently, the minimum intensity at the point of interference, the same point, will also, as I mentioned, depend upon value of cosine of this, but just depend upon phi1 and phi2. That will be I1 plus I2, which is expected intensity,
and it is now to be subtracted with the same factor. Whatever factor added in for maximum intensity, the same factor is subtracted here for minimum intensity, and I hope you understand this should be there according to principle of conservation of energy. So at this point where intensity goes beyond expectation, it is not in any way, it is not crossing or cancelling, or it is not any way taking opposition to that principle of what we say principle of conservation of energy. Whatever energy is added over here, it is taken from this. The intensity has reduced at the point of minimum intensity, and that has been added over here. So in certain region, if you have say 50 points of maximum intensity, in the same region you will definitely have 50 points of minimum intensity to give you overall intensity which is conserved. If you get maximum intensity at that point is called as bright point, and if the intensity is minimum at that point, the point is dark point. So notice carefully, in case of interference, at certain point where the interference is occurring, you may get maximum intensity or minimum. If you get maximum intensity, that form, or I can say that special case, extreme case of interference is called as constructive interference. You know that if there is an enhancement in the intensity beyond your expectation, we say something constructive is done. So we call that interference case as also constructive interference case. This is a special case of interference, it is not type of interference. And if the intensity at point is very low, or would we say below your expectation but maximum reduction, if there is maximum enhancement in the intensity beyond your expectation, constructive interference. And the point is said to जिथं constructive interference will त्या पॉइंटला म्हणायचं point is bright. And if the intensity is maximum below the expectation, this is maximum factor, and that is subtracted, so that is called as destructive interference. Destruction means reduction, demolition. So here intensity is reduced, here intensity is enhanced. Now obviously the question comes in your mind that, sir, when the constructive interference would occur, when the destructive interference would occur, are there some conditions on the sources of light to observe the interference? If it is not so, you could have observed this phenomenon anywhere as just like reflection and refraction that we don't observe. So there are certain conditions on the sources also. There are certain conditions which will give you proper systematic distinction between constructive and destructive interference. Everything else we shall be discussing in next lecture. Thank you.